Hello dear students, I welcome you all again to the third edition of chapter on tangents and intersecting chords. So today in exercise 18a we'll begin with the question number 13. So in this question let's quickly read out the question. So question says, in the given figure two circles touch each other externally at point P. Okay, so again there's a circle with center O and there's another circle with center O dash. So both of them touch each other externally at point P. AB is the direct common tangent to these circles. Okay, so there's a tangent whose name is AB, as you can see, and this tangent touches both the circles. So that's why it becomes your common tangent. Now we need to prove that there are two cases. Okay, so let us see the first part, that is tangent at point P. That means if you draw a tangent at point P, then that particular tangent will bisect AB. Okay, so that tangent, the tangent through P will bisect AB. Alright, so let us see the first part, then we'll go to the second part. So before that, let me draw a tangent. Okay, so draw a tangent common to the circles. Okay, so I need to draw, as I said, you need to draw a tangent which is passing through P, right? So we need to draw that tangent. So let us draw the tangent. So the name of the tangent is TP T dash. So TP T dash. So this blue line is the direct tangent through the point P. Okay, so basically what we need to show here is this TPT dash, this tangent bisects AB. That's what we need to show. That is, we need to show that AT and TB both will be equal. That's what we need to show here. Okay, so now from T, forget about this circle, one of the circle. This T lies outside the circle, isn't it? So from T you are drawing two tangents. One is TA and another is TP, and we know that they will be equal to each other, right? So we have TA equals to TP. Now similarly, let us forget about this triangle and this circle now. Okay, so we have from T there are two tangents, that is TB and TP. Okay, so we have TB and TP both also equal to each other, right? Okay, now let me call this as equation 1 and let me call this as equation 2. Now obviously, since TA is equals to TP and TB is also equals to TP, so from 1 and 2 I can say that TA and TB both are equal to each other, isn't it? That means TA, this, and TB both are equal means what? This means that this line is bisecting the line AB. Okay, so that's why I say that TPT dash, that is the tangent, is the bisector of AB. So that's what we need to show for the first case. Okay, so hope you are clear with this. Now let's go to the second part, that is the angle APB. So let us see which angle is that. So APB means we have to find this angle. All right, so this whole angle has to be 90 degree. So that's what we need to show in this case. Okay, so let's see how to do this. Okay, so let us have a look at triangle ATP. Okay, so we are talking about this triangle. Okay, so in triangle ATP, now we know that this AT and TP both are equal, right? So from 1 we see that AT and TP, they are equal to each other. Now if they are equal, then what kind of triangle is ATP? This ATP is isosceles triangle, right? And one more thing that we know from isosceles triangle is this angle and this angle. Okay, so this angle will be equal to each other. All right, so that's why it is written TAP. So TAP means this angle, and TPA, that is this angle, they will be equal to each other. All right, now similarly in this triangle also, that is TBTP, right? So in this triangle also, this is also again isosceles triangle, because this side and this side, they are equal to each other, right? So that's why it is written TBP, that is this angle, and TPB, that is this angle, they are also equal to each other. Now let me add these two. So after adding, in the left hand side we have TAP and TPB, so TBP, right? And in the right hand side we have TP and TPB, right? So let us see where is TPA. So TPA means this angle, right? And TPB means this angle. Now when you add these two angles, right, that is this angle and this angle, won't you get this full angle APB? Yes, so we get angle APB here. That means this will be equals to how much? Angle APB. Okay, now we have, see here carefully. So in triangle ATP, we have ATP, we have TAP. So TAP is this angle, right? TBP. Alright, so I'm sorry, we are talking about triangle APB. So in this triangle, what is the sum of internal angles? The sum of internal angle will be your 180 degree. So here TAP is this angle and TBP is this angle and APB is this angle. So when they are added, you'll get 180 degree exactly, right? Okay, so we have, now we already know that TAP plus TBP, TAP plus TBP is equal to how much? Is equals to APB. So that's why instead of this, I am writing APB. So we already have APB again. So APB plus APB is how much? It is twice APB. So 2 times APB is 180. That means angle APB will be 180 by 2. That is 90 degree. So that's what we need to show out here. Alright. So you may pause the video to note down. Okay, let's move on to the next question. So in this question, you're given that tangents AP and AQ are drawn to the circle. So we have AP tangents and AP and AQ are the two tangents from an external point A. Now we need to prove that PAQ. So let us say where is PAQ. So PAQ means they are talking about this angle. So this angle will be equals to twice OPQ. So OPQ means this angle. Okay, so basically we need to show that this angle is double of this angle. How? Let us see. So let's have a look at quadrilateral OPAQ. So OPAQ means you just forget about these two lines, that is PQ and OA. Then there is a quadrilateral, if you see here, OPAQ. Okay, now you know that the radius and the tangent at the point of contact will be lying at 90 degree. So that's why this whole angle, okay, so this full angle is equals to 90 degree out here. Okay, so if you see here, similarly we have this angle equals to 90 degree, isn't it? So this is also 90, this is also 90. And one more thing that we know from quadrilateral is sum of the interior angles of a quadrilateral will be equals to how much? It will be equals to 360 degree. Okay, so we have, as I said, these two angles will be 90 degree, this angle and this angle, they will be 90 degree. Okay, and sum of the interior angles will be 360, right? So POQ means this angle, PAQ means this angle, this is 90 and this is 90. So when the four angles of the quadrilateral added, you are getting 360. So 90 plus 90 is 180. Take this 180 out there. So you will get POQ plus PAQ will be 180 degree. Let me call this to be equation number 1. Okay, now let's move on to the next triangle, that is OPQ. So let us see where is triangle OPQ. So OPQ means this triangle. Now what is the speciality of this triangle? We have OP and OQ equal to each other. Why? Because they are again isosceles triangle. I'm sorry, they are radii of the circle. So that's why I can say this is again isosceles triangle. So if this is isosceles triangle, then this angle and this angle, they will be equal to each other. Alright, so that's what is written out here. Okay, now we know that sum of the interior angles is again 180 degree, right? In this triangle, that is POQ, OPQ and OQP. So when they are added, you will get 180 degree, right? Okay, but you know that OPQ and OQP, this one and this one, they are equal because this is isosceles triangle, right? So that's why instead of OQP, I am writing OPQ here. Okay, because we need OPQ angle, if you see here. Okay, so I'm turning this OQP into OPQ. So if I take Now let us see what is happening here. So OPQ and OPQ, when you add them, you'll get 2 times OPQ, right? So POQ plus 2 times OPQ will be equals to again 180 degree. Let me call this to be equation 2. Now this is also 180, this is also 180. Both are same. So that's why I can say that this part and this part, they are equal using 1 and 2. So from 1 and 2 we have, as I said, POQ plus PAQ will be equals to POQ plus 2 times OPQ. So POQ and POQ both are same, so that's why they will get cancelled. Okay, so what is left ultimately? So ultimately we are left with PAQ is equal to 2 times OPQ. So that's what we need to show, right? So you may pause the video to note down. Okay, let's have a look at question number 15. Two parallel tangents of a circle meet a third tangent at points P and Q. So let us try to understand the meaning of the first sentence. So there is a circle and there are two tangents. Okay, so two tangents meet the third tangent. So basically there are three tangents. Okay, so if you see here, this is one tangent, this is another tangent, and this is the third tangent. Okay, so they are talking about two parallel tangents. So if you see from the figure, the parallel tangents are this one and this one, right? So the two parallel tangents are given here. Okay, and there's a third tangent. Okay, and the third tangent intersect or meets, okay, the parallel tangents at point P and Q. Okay, so this is my third tangent and this third tangent meets the parallel tangents, that is these red tangents at point P and Q. Okay, so let me remove this. Okay, so basically we have got this diagram given in your book. Okay, so here let me join OP. Okay, so all the points there, OP, OC and OQ are joined here. All right. Okay, so let us have a look at triangle OAP and OCP. So let us see where is OAP. So OAP means we are talking about this triangle, and OCP, that is this triangle. So we are talking about these two triangles. Okay, so let us see what are the things which are similar in these two triangles. Okay, first and foremost, we clearly see that P is an external point, right? So PA and PC are the tangents, so that's why they will be automatically equal here. All right, and again in these two triangles, one of the sides, okay, that is PA and PC, they are already equal. Now which one is another side? So another side is OA, and in this triangle another side is OC. Again both will be equal. Why? Because they are radii of the same circle. Now two sides are already equal. Now the third side is OP, which is common to both the triangles. So that's why they will definitely be equal to each other, right? So that's what is written out here. Now using all our sides, right? So that's why using Sss Criterion of Congruence, I can say that this triangle and this triangle both are congruent to each other. So that's why triangle OAP is congruent to triangle OCP. Okay, now why am I doing that? Because there are two angles marked here. All right, so they becomes your, if these two are similar triangle, then congruent triangle, then what happens? This triangle, this angle and this angle will be equal by CP/CT, corresponding part of congruent triangles. Okay, so that's why OPA, okay, or APO and CPO, these two are equal to each other. All right, so let me call this as equation 1. Similarly, here also, if you work for triangle OCQ and OBQ, similarly you can show that CQO and BQO both are equal in the same way. Okay, so that's why it is written similarly. See, during exams you need not show this part if you are showing one of the part. Okay, so since the process is same, so you can directly write similarly during exams only in geometry. All right, okay, so as I said, this and this, again they will be equal to each other. Now what is our aim? Let us have a look at the question first. So we need to prove that PQ subtends a right angle at the center. So PQ means this tangent, right? So this P and Q makes angle 90 degree with center, right angle at the center means 90 degree with the center. That means POQ, that is this angle is equals to 90 degree. So that's what we need to show in this case. Okay. Okay, now if you see here, this is my APC, right? So this full angle can be written as twice of CPO. Why? Let us see. Now CPO means this angle 1, right? And we know that angle 1 and angle 2 both are same, right? Right? According to one, angle 1 and angle 2 both are equal. So this is also CPO. This is also CPO. So CPO plus CPO is how much? It is 2 times or double the CPO. So that's why APC is equals to 2 times CPO, and similarly CQB, that is this full angle is given to be 2 times CQO. Okay. Now if you see here, PA and CB, forget about other lines. So PA and PB, QB are parallel to each other, right? So if they are parallel to each other, then the third tangent is acting like what? It is acting like transversal, right? And the angles between the two parallel lines formed by the transversal, when you add them, the sum will be 180 degree, which is learned in your junior classes. All right, so that's why it is written. This is these two are tangents and parallel lines, and this is your transversal. So that's why I'm talking about this angle and this angle. So when you add them, it has to be 180 degree. Okay, so APC plus CQB is given to be 180 degree. But what is APC? Angle APC is equal to 2 times CPO, right? And similarly CQB is 2 times CQO. So if I put the values of APC and CQB, then I get this, right? Okay, so you can take 2 common. So you take 2 common and take it to the right hand side. So you get 90 degree. So CPO plus CQO is 90 degree. Okay, CPO means angle 1 and CQO means angle 3. So when angle 1 and 3 are added, you will get 90 degree. Okay, now let's have a look at this triangle, that is OPQ. Okay, or POQ. So in triangle POQ, that is this triangle, what will be the sum of interior angles? Sum of the interior angles will be 180 degree, right? So we have one, that is CPO, CQO and POQ. So when you add them, you'll get 180 degree, right? But we know that this angle 1 and angle 3, when you add them, you will get 90 degree, right? So CPO plus CQO. So instead of this, can I write 90 degree? Yes. So if I write 90 degree, take this to the right hand side. So you'll get 180 minus 90, that is POQ will be 90 degree. That is, this is my 90 degree. So that's what we need to prove in this particular question. That is PQ subtends right angle at the center. All right. So you may pause the video to note down. Okay, let's move on to the next question. So ABC is a right angled triangle. Okay, so there's a triangle, right angle triangle with side AB and AC only given to you. So the third side you need to find by yourself. Obviously you will be able to find using Pythagoras theorem. Okay, so now you are drawing a circle with center O, okay, which is drawn inside the triangle. Okay, so inscribed inside the triangle. So what is the figure that is already given out here? Okay, so there's a right angle triangle ABC, okay, and there's a circle inscribed within the triangle. Okay, so calculate the value of x. Now what is x? X is the radius of the inscribed circle. So basically the question is asking, find the radius of this particular circle. Okay, so and it is already given to be x. Okay, so we need to find the value of x here. Okay, now if you see here, let us see what are the things that we can conclude from here. So from here we conclude that since A is outside the circle, then AL and AN will be equal, right? So similarly BL and BM will be equal, isn't it? Now similarly CM and CN, they will be equal to each other, right? Okay, so another thing that we can see from here is this will be a square, because this is 90 degree. That's what is given, no? Right angle triangle means this is 90 degree, and we know that the tangent and the radius, they will also be 90. So if this is 90, then this is also 90. This is also 90, and automatically this becomes 90, right? And these two sides are also equal. So automatically this and this also becomes equal. This and this also becomes equal. So basically this part is your square here. Okay, fine. So as I said, in triangle ABC, it is given that angle B is 90 degree. Okay, so we already know this, and as I said, LBNO. So this is your square. Okay, now let me, if it is in square, then each side will be equal to each other, and we know that this is what, this is the radius, so that's why this will be my x, this will also be my x, and automatically these also becomes my x. Okay, so we have all equal to x here. All right. Okay, so what is AL? Let us see. So AL means we are talking about this line. Okay, so if my AB is 12 and this is my x, then automatically this becomes, if you remove LB from AB, removing means you have to subtract. So from 12 you subtract x, you will get AL, right? So AL will be equals to 12 minus x. Now we know that AN and AL will be equal to each other, right? So that's why the value of AN will also be 12 minus x here. Okay, is that clear? Okay, now let us quickly find what is the value of BC. Since we know AB and AC, use Pythagoras theorem. This is my 90 degree, so AC becomes my hypotenuse. So use Pythagoras theorem, that is this theorem, in order to find your BC. Okay, so BC turns out to be 5 from here. Okay, fine. So if BC is my, this full line is how much? 5, and BM is again x, then what will be the value of MC? MC will be this BC and remove this BM. Okay, so that is subtract x. So automatically MC becomes BC, that is 5 minus x. Okay, so MC is 5 minus x. Now MC, that is this line, and again CN, they will be equal to each other, right? So that's why CN is also equal to how much? 5 minus x. Okay, now let us go to the last part, that is AC. Okay, now what is AC? This AC can be written as AN plus NC, isn't it? So what is AC actually? AC is given to 13, and what is AN? AN is 12 minus x, right? So from here AN is 12 minus x, and what is NC or CN? CN is equals to 5 minus x, right? So instead of NC I have written 5 minus x. AN is 12 minus x. So from here quickly solve this and find the value of x, which turns out to be 2 centimeter, right? And our aim is to find the value of x here. All right, so you may pause the video to note down. Okay, let's have a look at the question number 17. So in a triangle ABC, inscribed, okay, so in circle, there's again the same case, but instead of a right angle triangle, there has been another triangle given where one of the angle is given to be 60 degree. Okay, and each side of the triangle touches the circle, that is side BC touches at P, side CA touches at Q, and AB touches at R. Okay, so that's what is given. AB touches at R, BC touches at P, and AC touches at Q. So that's what is given. So you need to calculate OQR. So let us see where is OQR. Oh, sorry, QOR. So this is my QOR. So basically we need to calculate this angle, and another is QPR. So let us see where is QPR. So QPR means we need to calculate this angle. That is, I'm sorry. So we need to quickly, let's go to our question. Okay, so basically we need to calculate this angle. Okay, so before that we know that. Okay, so if you draw the radius, this will be perpendicular, right? So OR is perpendicular to AB, OQ will be perpendicular to AC, and OP will be perpendicular to BC. So that's what we need to know using the theorems that was introduced in your first video. Okay, so let's have a look at quadrilateral AROQ. So let us quickly see where is AROQ. So AROQ, so basically we are talking about this quadrilateral. Okay, so in this quadrilateral, as you know, this is 90 degree, this is also 90 degree, right? Okay, so that's why sum of this and this and this and this. Okay, so sum of the interior angles will be equals to how much? It will be equals to 360 degree, right? And out of these, out of 360, we know this 90 degree, this is also 90 degree, and this is also 60 degree, and we need to calculate this. So this will be equals to 360 minus 90, right? Okay, so simplify this, this will turn out to be 120 degree. So for our first answer is QOR to be 120 degree. Hope this thing is clear to you. Okay, now let's go to find QPR. So QPR means we need to find this angle. Now let's go back to the chapter on circles. So we know that this QR subtends angle QOR at the center, and in the remaining part, very same points, that is QR subtends angle QPR, and we know that this full angle is going to be just half of this, right? So that's what is written out here. Okay, so QPR is half of QOR, and how much is QOR? It is 120 degree. So the value of QPR from here turns out to be half of 120, which is 60 degree. So you may pause the video to note down. Okay, let's have a look at the last question for the day, that is question number 18. So quickly let's see what is happening here. So in the following figure, PQ and PR are the tangents to the circle. So PQ and PR are tangents from an external point, means that PQ and QR, they are equal to each other. This is going to be 90, this is also going to be 90, right? Because OR and OQ, they are going to be perpendicular to the tangents. All right, so first you need to calculate QOR, that is this angle, if QPR, that is this angle, is given to be 60 degree. If this is 60, then you need to calculate how much is this, which seems like earlier question, right? So the first part I am not going to show you, so you will do by yourself. Actually it is already done, so I am not going to explain out here. All right, so next is OQR. So we have OQR is this angle. All right, so let us first look at this triangle, that is OQR. So let us talk about this triangle. Now in this triangle, this and OQ and OR, they will be equal to each other. Why? Because they are radii of the same circle, right? Okay, that means this is what? This is your isosceles triangle. So if this is your isosceles triangle, then this angle and this angle, they will be equal to each other. Okay, now what will be the sum of interior angles? Again, sum of interior angles is going to be 180 degree, right? Okay, now what is our aim? Our aim is to find OQR, right? So instead of ORQ, can I write OQR? Yes. And what is QOR? QOR is 120. So if I put the values, okay, so as I said earlier, I'm going to convert this into OQR. All right, so you can write as OQR here. So this 120 goes out there, right? So this is OQR, this is also OQR. So this becomes 2 times OQR. All right, so 2 times OQR will be equals to 180. This goes over there. So 180 minus 120 is 60 degree. Right? Okay, so from here, what is my angle OQR? Angle OQR turns out to be 30 degree. All right, so let's see the last part, that is QSR. So QSR means we need to calculate this angle. Again, since we know this angle, it's very easy to find this angle, which is again done in earlier part, right? So I'm again not going to explain this part. So your answer is going to be 60 degree. So you may pause the video to note down. Thank you very much.